AP Cram, Calculus AB, Free Response Exam Review, Question 27, Volume of a Solid about the x-axis. Let R be the region enclosed by the graph of f of x to the fourth power minus 2.3 x to the third plus 4 and the horizontal line y equals 4 as shown in the figure. Find the volume of the solid generated when R is rotated about the horizontal line y equals -2. All right, so for those of you, your first time, that are like myself, your first time seeing this, you probably had a panic attack. I know I did. But calm down, because the way you're going to solve this is by doing something, an integration that we call integration by the washer method. And okay, so we're asked to rotate this figure right here about the line, the horizontal line that is, y equals -2. So we can just pretend that this is y equals -2, because if this is y equals 0, which is the x-axis, y equals -2 just falls a little bit shy of that, traveling downward. All right, so that's that. So if we were to rotate this figure, we rotate it around, the y equals 2 line symmetrically, you're going to get something that looks cylindrical on the outside, but then the inside is going to have like this cute, fun hourglass shape that you'll only be aware of if you were to look, down the peephole or whatever. Okay, so, okay, that's that. Well, the washer method is telling us to take washers. They're like little slices, like donuts. And for those of you who don't know what a washer is, basically it's like that metal ring that you see on the screw. All right, yeah, so the washer is the metal ring seen on the screw. Okay, this thing right here. And basically it's a small flat ring, usually made of metal, but it can be made of rubber or plastic. And it's fixed underneath a nut or the head of a bolt, like, I'm showing you here. Excuse me, I'm so tired. To spread the pressure when this bolt is like tightened or between two joining surfaces. That's the purpose of a washer. We totally don't need to know that. But a lot of people, when they hear the washer method, they think of other things like a washing machine. That's not what this means. It's like a flat ring with a hole, okay? And the reason why this is called a washer method is because we're going to have to integrate. From between the points of integration, a series of several washer-like structures. And the way you do that is you take the surface area of the outer ring and you subtract the surface area of the inner ring. And since these are circles, you're going to have pi r squared involved. But, okay, we're expected first to set the equation y equals 4 equivalent to f of x. And the reason why we're doing that is to find the bounds of integration. So, or the limits of integration, you can say. So, like, you can easily put this in your calculator because that's what you should do on the day of the AP exam anyway. Or if you're using this review for an in-class exam, you should do that as well, unless your teacher requires you to show your work. So let's just go through step by step for those of you who want to be more informed about the step-by-step process of finding the limits of integration first, okay? So you set, the equations equivalent to each other, and now we're going to make an effort to solve for x. And because the x's are your limits of integration, then you rewrite the right-hand side of the equation and you put the decimal in fraction form, and you'll see why later. This is like a little bit easier than maintaining the decimal form 2.3. And then what I like to do is reverse the inequality to isolate x on the left-hand side because I'm used to seeing x on the left-hand side. Now you're going to subtract 4 from both sides and you end up with 0 on the right-hand side. Now what you can do is factor out x to the third and constants. This is a cool way to factor because we factored 1/10 out of 23 over 10. But you can also factor 1/10 out of 1 by making it, 10 over 10. So we factored out 1/10 times x to the third power. Okay, so this is just like a neat way to factor and keep things neat. And so these are the terms that we have on our left-hand side. Now we can multiply both sides of the equation by 10 to simplify. So when we multiply the left-hand side by 10, we eliminate the 1/10. And when we multiply the right-hand side by 10, we get 0, because 0 multiplied by anything is just going to be 0, okay? Now we can solve each term in the product separately by splitting them into separate equations. So we have x to the third is equivalent to 0, and 10x minus 23 is equal to 0. Now we're ready to solve for our limits of integration, okay? So obviously, if we take the cube root of x to the third, our third unity solution is going to be 0. And if we subtract 23 on both sides and divide by 10, our solution is going to be 23 over 10, or 2.3. So these are our bounds of integration. 0 over here, and 2.3 or 23 over 10 over here, okay? So this is the region that we're integrating in order as we rotate this volume, the solid, creating, a voluminous mass, all right? All right, so now that we've gotten that out of the way, I'm going to show you the integration equation. That our bounds of integration are 0 or 2.3, or they're also the solutions to this equation, okay? All right, now it's time to figure out the radius. Actually, the volume of each washer in an effort to figure out the volume of the entire solid of revolution around this line, y is equivalent to -2, okay? And so again, I previously mentioned that the outer radius would consist of not the circumference, but the area of the outer radius minus the area of the inner radius, and that gives us the surface area of our washer. And in order to get the depth, hence the volume, this region right here, the thin volume at the side, all we have to do is do dx. Because as x changes for each washer, you get some sort of depth. Okay, so the equations will involve pi r squared dx. So again, the volume of the outer washer is going to be 4. Because of the line y equals 4, you revolve it around, and the bounds of the inner radius is -2. So when you subtract the -2, you get +2. So it's going to be 6 squared. This is where we get our r squared. And then we just factored out the pi, okay? Because we're going to see pi again over here, and so it becomes a constant, and we can just factor it out. Now the inner radius is, the lower function, or f of x minus a -2, because the radius traverses from there to here. All right, I know this might be a little confusing for some people, but just imagine. Let me kind of show you. So here goes like our outer radius. Sorry if my circle's not so circuitous. And the outer radius, if we let it be at 4, and then the inner radius is here. And, that's going to look something like this. Sorry. I think you get the point. My inner radius isn't that great. Okay. So the inner radius, again, is f of x minus y is equivalent to -2. And when you subtract the -2, you get +2. So it's f of x plus 2 squared. And then you multiply that by dx, and then we have our volume. Because the volume of a circular object is just its surface area times its depth. And remember, we said dx is the depth if you travel horizontally for each washer. Okay? All right, so that's that. And then when we solve the integral, and then we basically plug this into your calculator. If you want, leave a message saying you want me to detail how to integrate this, but it's really straightforward. Over here, you end up with 6. Just, break it down, and then use the fundamental theorem of calculus to get the antiderivative of each term. All right, it's not that hard. And remember, f of x is this equation right here, okay? All right. So when you solve the integral, multiply everything by pi, make sure your calculator is in degree mode, and you plug in the solutions at 2.3 and 0, you end up with 98.868 or 98.867, something in that range, not too far off. And that's your volume, 98.868 or 867 units cubed.